All right, greetings Algebra 2 students. Glad you found some time to get your notes taken care of. For this day, we're going to be looking a little bit further at some of the mathematics involving polynomials, and we're going to take a look at something you're probably already a little bit familiar with, and that is the process of multiplying polynomials. So please copy the title down, Multiplying Polynomials. Drop down a couple of lines and write your objective. Our objective for this day will be the student will learn the process for multiplying polynomials. As always, anytime you need more time in order to copy something down, hit the pause button and then hit play when you're ready to move on. Okay, now the distributive property is something that is not new to us. We have been using the distributive property since probably sometime around 6th or 7th grade. And the distributive property states that a term being multiplied by a set of parentheses must be multiplied by everything inside of those parentheses. For example, that little abstract example I've got there says A is being multiplied by B plus C plus D plus, and it can be any amount of terms being added or subtracted or whatever inside of those parentheses. The distributive property says that that A value outside of the parentheses, whatever it is, belongs to every term inside of the parentheses. So the A must multiply times the B, then it must multiply times the C, then it must multiply times the D, and so on until it has hit every term inside of the parentheses. Now, what we're going to see today is that the same idea is still true if the thing or the term outside of the parentheses is another set of parentheses. Okay, just like from above where the A had to multiply by every term inside of the parentheses, what we're going to say now is every term from one set of parentheses must be multiplied by every term from the other set of parentheses. Now, the most common little idea of two polynomials being multiplied together is not anything new. You've seen this before, where you have a binomial being multiplied by another binomial. Okay? Well, the distributive property applies here because we have something trying to multiply its way into a set of parentheses. Okay? It just so happens that this time the thing trying to multiply in is another set of parentheses. So the rule will be everything from one set of parentheses must multiply times everything from the other set of parentheses. So the A on the left-hand set of parentheses, it must distribute and multiply times the C, and then multiply times the D. And once the A has hit every term from the other set of parentheses, then you simply scooch over, and then the B does the exact same thing. It must multiply by everything in the other set of parentheses. So the B will multiply times the C, and then the B will multiply times the D. Okay, so as a result, you end up with A times C, whatever that is, being added or subtracted with whatever A times D is, being added or subtracted with whatever B times C is, and added or subtracted with whatever B times D is. Now, there is a little goofy little one of those little sayings that teachers come up with in mathematics to go along with this, and perhaps many of you have heard it, or you may still have it programmed in your um, in your memory bank. Sorry, I got a little sidetracked there. Okay, and that term would be the FOIL method. Okay, well, this is one of those things where it's something easy that junior high teachers tell students in order to help them memorize that every term needs to be multiplied by every other term. Okay, so FOIL, F-O-I-L. Okay, the F stood for the first terms needing to multiply together. The O meant the outer terms needed to multiply together. The I meant the inner terms needed to multiply together, and the L meant the last terms multiplied together. So, and if you did that, then that would assure that you actually did get all of the terms distributed to all of the other terms. Okay, so if you memorize that from before and it helped you get through things, that's great. Glad it helped you out. However, what we're going to see here in a moment is that the FOIL method is actually very narrow in its focus, and it does not work all the time. Okay, so if we were to look at something more like this guy, where instead of a binomial times a binomial, maybe we have a binomial times a trinomial. Okay, well, if you were to try to use the FOIL method, as the junior high teachers taught you to, look at what happens. You do have a place where first terms multiply and the outer terms multiply and the inner and the last. But as you can see, a couple of those bridges that are built in there are not getting multiplied times each other. That means that not all of the terms hit all of the other terms. Okay, so one of the things we're going to do is this will be the last time you'll hear me use the term FOIL. Okay, we will not use that term anymore simply because it does not work. The thing I always say in class when it comes down to distribution property where parentheses are involved, we're simply going to say we're going to multiply everything on the left times everything on the right. And if you can do that, if you can multiply every term on the left, or from the left set of parentheses, times every term on the right side of the right set of parentheses, then you will get the answer that you're seeking. Okay, so let's start taking a look at the math here. Okay, here we have a couple of binomials being multiplied. 2x plus 3 times 4x plus 5. Okay. Obviously, it is a set of parentheses multiplying by another set of parentheses, so the distributive property does apply. Everything on the left must multiply by everything on the right. And if it helps you keep track of it, don't be afraid to draw the little bridges, okay, over your terms or under your terms, whatever, to help you make sure that you do get everything connected to everything else. Typically, I just start on the left side. Okay, the left set of parentheses, and I start with the lead term, the 2x. And I'm going to make sure that the 2x hits everything from the right set of parentheses. So I'm going to go 2x times 4x, then I'm going to go 2x times 5. And since the 2x has now hit everything in the right set, I'm going to scooch over to the 3, and I'm going to go the 3 needs to multiply by the 4x, and the 3 needs to multiply by the 5. Okay, so here's a step you don't necessarily need to show when you are working your problems, but I'm showing it here just to make sure nobody's confused on what's going on with the math. The 2x times the 4x, the 2x times the 5, the 3 times the 4x, and the 3 times the 5. Every term is going to hit every other term. So let's take a look at what these results are. 2x times 4x, what is that going to result in? Well, 2 times 4 is 8, and x times x is 8 squared. That's going to be an 8x squared. How about the 2x times 5? 2 times 5 is 10. The x doesn't have anybody to join with, so it's just hanging on for the ride. It'll be 10x. How about the 3 times 4x? 3 times 4 is 12. The x is just hanging on. Okay, so we'll have 12x. And then, of course, 3 times 5 is 15. Now, a lot of times the case with the distributive property when you're getting polynomials times other polynomials is you may have terms in common. So let's have a look at this 4-term polynomial here and see if we have any terms in common. Okay, the lead term is an x squared, so scan through. Do you have any other x squareds? No, there's no other x squared, so 8x squared is going to be part of the answer. 10x's, okay, we have some x to the firsts. Are there any other x to the firsts? Yes, there are. There are 12 of them right next to it. So we have 10 x's, and then we have 12 x's. So how many x to the first is that? 10 plus 12 is 22 x to the firsts. And then 15 is our x to the 0 term, our constant. Are there any other constants to add with the 15? There are not, so 15 will be part of the answer, and you're done. 8x squared plus 22x to the first plus 15x to the 0. That is our simplified answer. Okay, let's look at one more. As always is the case, not everything is going to be addition, which is easy for us to work with, and subtraction a little bit harder, but it doesn't make a difference. We just simply have positives or negatives to work with. So 5x minus 3 times 3x minus 2. Binomial times a binomial, everything on the left times everything on the right. Okay, so draw the little bridges if it helps you. It's fine. Okay, So we're going to make sure we've got 5x times 3x, 5x times negative 2. Then we'll scooch over negative 3 times 3x, and negative 3 times negative 2. Okay, so let's see what we have there. What is 5x times 3x? 5 times 3 is going to be 15. X times x is going to be x squared. So that'll be a 15x squared. 5x times negative 2. Now 5 times negative 2 is negative 10. The x doesn't have anybody to combine with, so it's just going to hang on. That'll be negative 10x to the firsts. Then we scooch over. Negative 3 times 3x. Negative 3 times positive 3, negative 9. The x will be attached to it, so negative 9x. And then lastly, negative 3 times negative 2 is positive 6. Okay, so there are the 4 terms. And I'll tell you this, you can always know how many terms to expect out of a polynomial distribution. Okay, and here's how you know how many terms to expect. How many terms were in the polynomial on the left? There were 2. How many terms are in the polynomial on the right? There are also 2. Okay, if you take those two 2's and multiply them together, what do you get? 2 times 2, 4. That means we should expect 4 terms from our distribution. And as you see right there, we do have 4 terms. Very easy way to make sure that you have not missed any of the steps or left anything out. Okay, let's look and see if we have any terms that are in common here. The lead term is a 15x squared. Are there any other x squareds? No, they're not. So there's going to be 15x squareds in our answer. Our next term is an x to the first. Are there any other x to the firsts? Yes, there are, right next to it. We have negative 10 of them, and then we have negative 9 of them. So how many will that be? That is a negative 19 x to the first. And then at the end, we have an x to the 0 term, our constant. It is 6. Nobody for him to combine with, so he is part of the answer. And there is your answer. All right. Just a little bit of a different format here, not any real different math. We have 5x plus 2, and the quantity is squared. Okay. Well, always keep in mind, what does it mean to square anything? Okay, to square anything means to multiply that thing times itself. So when you see 5x plus 2 and the parentheses are squared, that does not mean that the 5x is squared and the 2 is squared. That means that 5x plus 2 needs to be multiplied by itself. Okay, so a polynomial squared means to multiply the polynomial by itself. So we got 5x plus 2 times 5x plus 2. All right, well, here we go again. We should be getting okay at this. 5x times 5x, it's going to be 25x squared. 5x times 2 is going to be 10x to the first. We scooch over. 2 times 5x is going to be another 10x, and 2 times 2 is going to be a 4. Okay, once again, we should have expected 4 terms out of the distribution because we had 2 terms in the left, 2 terms in the right. 2 times 2 is 4. There are our 4 terms. Okay, any like terms in there? Yes, there are. We have some x to the firsts that need to be combined. How many are there? There are 20 x to the firsts. So there's your answer. I think you're getting the hang of it, and you probably don't need any more help from me, but I am going to point out a little bit more of the complicated problems. If there are more terms, then there are more terms. As you can imagine, this can get as ugly as they want it to. You could have an 8-term polynomial times a 12-term polynomial, and you'd have to multiply them all out. Here we go. You have a binomial times a trinomial. How many terms should we expect after the distribution is done? There's 2 terms on the left. There's 3 terms on the right. What's 2 times 3? 6. We should expect 6 terms from the distribution. Okay, so everything on the left times everything on the right. It just means that we have more bridges because there's more terms. Okay, but you can see the 6 bridges. That's where our 6 terms are going to come from. Okay, and you just multiply it out. Okay, 2x times 6x squared. 2 times 6 is 12. X times x squared is x cubed. The 2x also needs to go get the 4x. What's 2x times 4x? 2 times 4 is 8. X times x is x squared. The 2x needs to go get the 5. 2x times 5 is 10x. Now that the two x's have gotten everything that they can get from the right side, we scooch over and we need the same thing with the 3. 3 times 6x squared is 18x squared. 3 times 4x is 12x, and 3 times 5 is 15. So there are your 6 terms. I even color-coded them for you this time. Okay. Now, the more terms there are, the more likelihood there is that you've got like terms to combine. So let's scan this and see if we have any like terms here. The lead term is x cubed. Do you have any other x cubes in the problem? No, that's the only set of x cubes, so 12x cubed will be part of the answer. Our next term is 8x squared. Any other x squareds to be part of the answer? Yes, there are. We have eight of them that we're looking at, but there's also 18 of them over there in the blue. Okay, so 8 of them and 18 of them. How many is that? That's going to be 26. Our next term is x to the first, 10x to the first. Any other x to the firsts? There sure are. There's 12 more of them over there in the blue end. Okay, 10 of them and 12 of them. How many is that? That's 22. And then lastly, we do have constant, some x to the zeros out there. There are 15 of them. There are nobody for him to combine with, so that is our answer. 12x to the cube, or 12x cubed, 26x squared, 22x to the first, and 15 constants. Okay. I think you've got it. I do have a couple of examples that I want you to try. For those of you that are new, when you do get examples like this in your notes that I have not worked out for you, I do expect you to give it a try to work the math out as part of your effort on your notes. If you do not complete these examples before your notes get checked in class, it is possible that you might have some of your participation deducted on your notes. Okay, so here's a couple of binomials, 3x plus 4 and 2x plus 1. Now keep in mind you should expect 4 terms from the distribution. It's a binomial times a binomial. That's 2 times 2. But that does not mean there's going to be 4 terms in the answer. That just means 4 terms from the distribution. Some of those terms might combine. Okay. And also, one more example for you to try. This one is a binomial times a trinomial, x minus 1 times x squared plus 3x minus 2. Okay, so we should expect 6 terms from the distribution on this one because it's a binomial times a trinomial. That's 2 times 3. And give this one a try as well. And I'll see you in class.